So at this point, I'd like to go ahead and show you a different kind of crash. This is a Stop 133 or a DPC watchdog violation. So as we bring up the debugger again, we'll go ahead and start it in administrative mode and open up our next crash. So we'll go ahead and take a look at demo 2 and load it into the debugger. Now here we can see it is a Stop 133, a DPC watchdog violation. We can see that the debugger already thinks it was caused by store port, a driver that's used for the storage subsystem. So let's go ahead and take a look at this. We're going to start out with a bang analyze-show command. And it tells us a few things about it. That a DPC watchdog detected a prolonged runtime at IRQL of dispatch level or above. So it was running at an elevated interrupt level, causing all the user processes to essentially hang. When we take a look at the various arguments, we can see that the first argument means that a single DPC or ISR, that's a deferred procedure call or interrupt service routine, exceeded its time allotment. The offended component can usually be identified with a stack trace, so we'll take a look at that. We can also see the DPC time count in clock ticks, and that was the timeout that was essentially exceeded. So here we can do various things like look at the thread that was running at the time. So let's scroll back a little bit and see that it was the idle thread that was running when the system crashed. And if we scroll over here to the far right, we can take a look at the stack. And yes, indeed, it was the idle thread that was running. It was trying to retire the various DPC list, any outstanding DPCs it tries to process. And it noticed that one had expired a timer list. And that particular one was the store port driver, where it was trying to issue this function called rate adapter timer DPC routine. And there it sat and waited for lock ownership. So that's a big clue right there. This thread, for whatever reason, stalled trying to wait for lock ownership. Finally, we ultimately got interrupted by the timer clock interrupt, where it bug checked the system because we had exceeded the DPC watchdog time period. So we've kind of looking at why did store port get involved and why were we waiting for a lock ownership. So let's go ahead and take a little bit more of a look around. One of my favorite commands is the bang running-it, because it shows me all the different threads that were running at the time. So as that quickly goes by, you can see that there are actually, it says 15, but it's a zero-based array, so it's 16 CPUs. So let's go ahead and scroll backwards and take a look at what these CPUs were doing. So here we see CPU 0 was just issuing something in user mode. It was a very low address issuing a system service. CPU 1 was running the idle loop, trying to gain some performance counters. CPU 2 was also executing something in user mode, a very low address. CPU 3 was executing the idle loop. So was CPU 4 and CPU 5, CPU 6, and CPU 7. All of them were executing in the idle loop, meaning those particular processors were not running a thread. We look at CPU 8 now, things get a little bit different. We can see here was in fact the thread we looked at before that was in the idle loop before it noticed that it had expired the timer and store port was waiting for a lock ownership. You could see how this is CPU 8 and the crash CPU 8 from the debugger's prompt. So we know that that was in fact the thread that was current when it crashed. So let's look at the other CPUs. Here's CPU 9. What was it doing? If we scroll down to the bottom of its stack, you can see it was running a system service, trying to do a I/O control file, where it got the EMC driver involved. So EMC then called store port, where it tried to do some sort of driver system control IRP, and store port continued to get involved. You can see it's trying to build some sort of DMA scatter gather list, and then ultimately store port was stalled, waiting for lock ownership once again. So now we've got CPU 8 and CPU 9 that are both waiting for some sort of lock ownership. So let's continue to look at the different CPUs. Here's CPU 10. Oh, this one's different. So let's scroll down to the bottom of its stack where it's executing a system service. Same thing, it gets the EMC driver involved, gets store port involved. Store port hands it off to the ELXFC. That's the Emulex fiber channel adapter. That's the HBA mini port adapter. So it's actually talking with the host bus adapter. That's the lowest physical level you can get at that point. And so that driver is busy executing, and what's it doing? It's trying to enumerate and discover all the devices, all the storage devices out there on that host bus adapter. It's doing actual work in the ELX FC driver. It's not waiting for a lock ownership like those other threads where it actually owns the IO lock. So as we continue to look through the different other different CPUs, this one just running the idle loop, as is CPU 12, CPU 13, CPU 14, and CPU 15. So we have essentially 3 threads of interest. The one that was current at the time of the crash on CPU 8, waiting for lock ownership. The one on CPU 9 that was doing very similar things, store port, waiting for lock ownership. And finally, we had a thread on CPU 10 that was actually doing work inside of the ELX FC driver. At least we think it was doing useful work. So what we can do is take a bit closer look at some of those threads. As we know, the one on CPU 8 was the idle thread, but we can switch over to CPU 9 by doing the ~9 command. Now if I issue the bang thread command, it will show me what was running on CPU 9. So here I scroll back up, and we can see the image that was running was this HBA discover or discover service. So that's what it was trying to do. It was trying to discover various HBAs out there. And you'll remember that this one was also going through store port and waiting for lock ownership. Now let's go ahead and see what was running on CPU 10 at the time by just doing a ~10 and then doing a bang thread. And we'll scroll back up a little bit. And this thread happened to be executing a program called FCinfo, which is by Microsoft. It essentially gives you information about your fiber channel cards. So you can see we had not only the HB Discover service enumerating various devices, so was this FCinfo application. And if we look over at its stack, you can see that indeed is the one that was exercising the ELX FC driver, trying to enumerate the different devices out there. Well, to make a long story short, it was indeed this ELX FC driver that was at fault. It had essentially discovered a dead HBA that wasn't responding, so it kept trying to enumerate the various devices out there. Because it held on to the IO lock, the other threads that were trying to do stuff like store port were also stuck. And so essentially it was a cascading effect caused by this Emulex ELX FC driver. Now, one thing I want to mention is that anytime you upgrade a mini port driver like the ELX FC, you want to also update the store port driver. That's because the ELX FC driver is dependent on store port, and we want to upgrade those drivers in tandem. Now, I wanted to point out that the Stop 133 bug check is one of the later ones that Microsoft has implemented in Windows Server 2012. And a lot of drivers weren't quite tuned correctly, so we saw a lot of these 133 bug checks when 2012 was released. And Microsoft actually came out with a way of disabling these watchdog timers because so many systems were crashing. So I could pull up an article here. As you can see, it's article number 2789962 that you can get more information about it, but it acknowledged the fact that a lot of people were seeing these DPC watchdog violations, and it provided a registry parameter that you could essentially disable this watchdog mechanism. You could either shut it off completely by tweaking a parameter called DPC timeout to 0, or you could actually extend the existing DPC watchdog period with a second registry parameter. So in summary, this bug check occurred because the ELX FC driver was trying to essentially discover HBAs, and one of them was dead and non-responsive, and this caused a cascading effect to essentially hang various other threads, and the system finally noticed all this and bug checked the system with a stop 133.